Hello, I'm NASA astronaut Chris Williams, and these are my colleagues, ESA astronaut Sophie Adenot, and NASA astronauts Jack Hathaway and Jessica Meir.
We are part of the Expedition 74 International Space Station crew, and we are so excited to have the opportunity to answer questions submitted from our very own NASA interns from across the agency.
Our interns are so important to the success of NASA's missions. From our deep space telescopes to our missions to the moon, interns make vital contributions that help this agency achieve its greatest and most daring feats. When I was an undergraduate student, I spent a summer working in a plant lab at the Kennedy Space Center. This experience fueled my passion for science and exploration and helped pave the way to my careers as a scientist and an astronaut.
Knowing the quality of our interns at NASA, I just know they have prepared some really thoughtful questions for us today. Let's dive in. Our first question comes from Greta, intern at Ames Research Center in California. She asks, how do you transition from being a highly specialized expert to being a generalist crew member who performs a wide array of tasks each day? Well, I would say you receive a lot of training for all of the tasks you have to do. And then you also have to be a little bit ingenious sometimes on board, but you have a ton of procedures to help you. And also you have a ton of people on ground teams to help you perform all of this. So we are not alone and we learn what we do.
Gracie, an ICONS intern at headquarters, asks, looking ahead to future missions beyond low Earth orbit, what chemistry-related challenge do you think astronauts will need to solve that people outside the space community may not realize exists? Thanks, Gracie. That's a great question. One of the chemistry problems that the whole NASA team is going to have to solve, not just astronauts necessarily, but really the entire team, is how to make rocket fuel to keep us moving from place to place. Rocket fuel is very heavy, and if we had to carry it all with us after we launched, while we launched from Earth, our rockets would have to be really big, or we'd have to launch a lot of times. So if we have the capability to take local resources from the moon or asteroids or the Mars, wherever we end up, and able to turn that into rocket fuel, we'll be able to expand our reach dramatically, and that will be awesome for the future of space exploration.
The next question is from Michael, who's an Ames Research Center intern. And he asks, outside of the traditional STEM skills, what skills would you say make for exceptional astronaut candidates? Soft skills, ways of thinking, approaches to problems, personalities, etc. Well, that's a really good question and a really important one, because I think that some of the skills that are most important for being an astronaut, you have to have technical skills, but some of the most important ones are your skills at being a good team member. As astronauts, we're part of a huge team all across NASA that includes you guys, and we all work together to make these missions happen. And so, knowing when you need to lead, knowing when you need to follow, and knowing how to work together with people that come from all different backgrounds, all places, and have all different ways of thinking, like that is far and away, I think, the most important thing, most important skill that an astronaut has.
Matthew from Glenn Research Center asks, I am curious how issues with onboard computer systems are handled. Are all crew members trained to perform maintenance? Excellent question. As one of the earlier questions sort of led to, we all are trained in various disciplines separate from what our actual backgrounds are. So training on the ground really covers all aspects of space station, from the fixing the toilet to changing light bulbs to going for spacewalks. We don't actually, though, get much training on the computer systems, and one of the reasons is a lot of this is handled by our ground teams. We have hundreds and thousands of people working on the ground, and we have a very specialized team working in the Mission Control Center at a console position named Pluto, who is really in charge of all of the different onboard computer systems. But of course, since we are the users of the computer systems, there are some things that we have to get accustomed to and troubleshoot on a daily basis. So some of those things we really pick up more from experience up here and from the other people around us, people that have been up here longer and have seen that kind of thing before. So this is an example of more of a learn as you go kind of skill that we pick up on the International Space Station. And then most of the time we're calling the ground to ask the experts what to do. They can actually even remote into our laptops, for example, or even our iPads and fix things for us and reconfigure things from the Mission Control Center.
Salmon, intern at Wallop's Flight Facility, asks, what is a piece of hardware or equipment aboard the International Space Station that works differently in microgravity than engineers originally expected, and what did NASA learn from it? Well, I would say everything, because microgravity is so surprising. Even if you have the best engineers in the world, you will have some surprises up here. One of the most recent surprises that we had is trying to understand how the vibration isolation systems work for a very heavy machine that we plan to use for future exploration missions that is called E4D. And so even if it was perfectly designed, but we still have to do some adjustments and tweaking to be able to have it optimized for the space environment we're in. And so it's still a process in work. And I would say for all of the systems that come up here, it's always work in progress and always learning experience for our ground engineers.
Stuart from Glenn Research Center asks, when a procedure diverges from the nominal script, what quick problem-solving techniques or decision checkpoints help you choose between pausing for a ground consult versus applying onboard contingency guidance to continue safely? Thanks, Stuart. This is a daily interaction for us as we work through procedures, as Sophie just described, that are carefully designed on the ground, but they're designed in a 1G environment, and we're not always sure exactly what's going to come up here, what things are going to happen, and how we're going to have to adapt to the circumstances in front of us. As we approach problems, you're right, we have to decide, do I want to stop, ask the ground? Do we have AOS right now? Can we even talk to ground? Or do I have enough knowledge and skills up here between myself and my great teammates to solve this problem? And to do that, we rely a lot on experience, honestly. We think back on our careers, on the types of problems that we faced, and we're like, is this a significant problem that I'm in danger of hurting myself, my crewmates, or the system or the hardware? Maybe I'm going to slow down and ask for help. But if I think I can solve it, or the risk of a really bad thing happening is pretty low, we're probably just going to press ahead to stay on timeline and keep things moving. So that's kind of the criteria that we use, but it changes every day, and that's part of the excitement.
Brody, an intern at the Katherine Johnson IV&V facility, asks, was there any moment in your early career that completely changed the direction of your path towards spaceflight? Yeah, I would say there's been a couple moments. I think the biggest one for me, I had always wanted to be an astronaut and to be involved in space exploration ever since I was a kid. And that led me to study astronomy and to get my PhD in astronomy and astrophysics, studying the stars, because I'd always loved it. But towards the end of my PhD, I actually had an opportunity that came up to actually switch out of space and to do some work in medicine, working in radiation oncology and studying cancer and working to help treat cancer patients. And that was a really scary jump to take, to kind of go out of a field that I knew I loved and had a big passion for, to try something else that I also loved and had a passion for. But making a jump like that in my career and finding that, hey, a lot of the skills that I had translated and that I was also incredibly passionate about the impact that this was making, gave me a lot of confidence to then feel that when the opportunity came to throw my hat into the ring for being an astronaut, that, hey, maybe I could do this. It's different than what I've been doing before, but you know what? Maybe it's something I can do. I can be flexible, adaptable, and here I am. So yeah, I think all of us have had interesting experiences in our careers, all like that have kind of led us to this point.
Saima at the Langley Research Center asks, future exploration missions will be constrained by launch mass and volume. From an astronaut's perspective, what types of tools, habitats, or robotic systems would benefit most from being highly deployable after launch? It's a very interesting question, and it's a really good one, because as we think about our future in space, longer missions, further destinations, we definitely need to be more sustainable. And some of the systems that I think a lot about, some of the systems that we're trying to help develop and test here on the space station, are food systems. We won't be able to have the mass and volume available to launch all of the food and water, for example, that we need when we are in space. So we have been growing plants up here on the space station, trying to better understand how to grow crops in microgravity that could help us on missions like this. Another thing would be fuels. Jack spoke a little bit about this earlier in one of the questions. Can we use, for example, volatiles or frozen water underneath the surface of the moon to help make fuel for future spacecrafts? Can we use the water for drinking? How do we understand how to use those elements that are already there in place so that we can be more sustainable, and that will take less launch volume and mass? Those are some of the things that come to mind for me. Up here on the International Space Station, we also have another test structure that's called BEAM. This is an expandable module that was built by the Bigelow Aerospace Company. And this was trying to address exactly the question that you raised. How can we reduce the launch volume and mass? So they actually had a small module that was constrained. It was shrunk down. It was about full. I would say it's kind of compressed, folded up to about a third of the volume that it was going to expand to. And then once it was attached to the International Space Station, we added some pressurized gases to it to expand it. So that way we saved a lot of launch volume and mass. And that was a test bed for future developments, future types of environments and habitats like that. This was the first time that it was ever an expandable volume that was human rated.
Fiza from Johnson Space Center asks, do you foresee NASA's current astronaut training curriculum changing to prepare future astronauts for Mars surface missions, which will require greater crew autonomy? Wow, what a great question. Yeah, we all want to go deeper into exploration and longer space flight, and going to Mars is going to be so challenging. I would say, it's a different view on this question. So we can see, okay, what we can do now to prepare crew to go to Mars later. Or we can also say, let's go incremental. We're going to start with the moon, and with the moon, we're going to start learning more about how to get more autonomy for the crews, because they will be further away and they will have other problems to solve. And so probably even the questions we're thinking about today, we don't even know if there will be questions again tomorrow. So yeah, it's always a good idea to prepare the crews to be more autonomous. But also, I understood more than ever by becoming an astronaut that you cannot understand everything about spaceflight. Spaceflight is super complicated. Spaceflight needs hundreds and thousands of people on the ground to make it work. And so even if you want to make the crews more autonomous, you will never be able to have them 100% autonomy, because you need a lot of the brains on the ground to help solving complex problems. So great question. I'm not sure we'll fully have the answer today, but let's be creative and see what the future holds.
Luke, intern at Kennedy Space Center, asks, what was our Artemis II viewing tracking experience like on the station? Being on board the International Space Station during the Artemis II mission was awesome. We got to hear from our friends. We got to watch. We couldn't see the launch itself, but we saw the trail of the rocket after we passed overhead. And we got to follow the updates and hear them on social media and on the NASA loops. And eventually on their way back from the moon, we actually got to do a spacecraft-to-spacecraft communication, which was really a surreal, incredible experience to have humans coming back from the moon talking to humans that are orbiting the Earth on the International Space Station, and be able to share stories about our experiences of the day. Whether we're eating the same food or having a completely different mission, it was a pretty awesome experience. Being part of this phase of human space travel that you guys are all a part of, that we're a part of, is just so incredible. There's so much going on, and it's such an honor to be a part of it in whatever way we can participate.
Kieran from Langley Research Center asks, my current NASA internship connects to Artemis materials research, including how radiation exposure, lunar regolith contamination, thermal conditions, and crew interactions may affect materials used in exploration systems. From your experience aboard the International Space Station, what have you learned about the importance of material durability, cleanability, and crew-centered design when preparing hardware for future long-duration missions on the moon or beyond? Well, one of the things that you may not appreciate about life on the International Space Station is that because of microgravity, things are actually kind of messy. And every weekend, we actually have to spend several hours cleaning, the same chores that we would do at home. And you get stuff everywhere, because when stuff spills, it spills in 3 dimensions, up, down, to the side, everywhere. And so cleanability and is actually super important. It's not something I when I read your question, that wasn't the first thing that I thought would come to mind, but boy, is that important. We have hatch seals in all of our modules, and you don't want to contaminate those. You don't want to get food and gunk on them. And so we have to think about, well, if we're doing human spaceflight, if we have humans living, food, things like that are going to get everywhere. And so we have to design first and foremost with things like that in mind of, okay, well, if this does get how do we protect this hatch seal from a coffee stain? Or if a coffee stain gets on it, what are we going to need to do to clean that up and fix it? So I think it's really important to keep the human in human spaceflight when thinking about the design of these future systems, because I think from my experience, some of the things that have been the most challenging to work with are the things where we haven't maybe necessarily been human centric in our thinking about how to design these systems. And then when we actually put them into operational practice, we run into a lot of challenges, or they're just not great for us to use up here. So thanks for the great question.
Rohan at the Glenn Research Center asks, I read that you 3D printed cartilage tissue aboard the station using the Auxilium microfabrication platform, AMP. How does this process differ in space versus on Earth, and how can this advance the future of regenerative medicine? This is a great question, and I've actually had a few different experiences now using 3D printing of human tissues. The first was on my first mission in a facility called the Biofabrication Facility, and we were using that to print different types of tissues. One was a cartilage tissue, one was heart tissue. And the idea here is that on Earth, scientists and doctors who have tried to grow artificial organs, for example, on Earth, they have problems doing it because making this three-dimensional structure doesn't develop quite as they would like because it's hindered by gravity. So the hypothesis was that without gravity, the cells would be able to form into these nice layers of a tissue and eventually into organs. On Earth, they've had to use things like scaffolding type materials in order to get the cells into good tissues and organs. And then often when they have to remove those, they have some influence on the tissue itself. So the biofabrication facility was looking at that because on Earth, we often have problems with a shortage of organs for organ transplant procedures. So if we had an environment where we could more efficiently produce artificial organs and use them back on Earth, that would be a great asset. The Auxilium facility was similar, was using this 3D printing of cartilage. And I would say that one of the ways that the process differed is the fluid mechanics in space. So understanding how fluids operate in space is really interesting. Of course, we understand that, when we just take a drink of water, we can take our water bag and squeeze up a little bubble and it all stays together, and then we can drink it in the air because it's not being pulled down by the force of gravity. These same principles, surface tension and what happens to fluids, are really an important part of all these experiments. For example, how the fluid behaves even just being sucked up into a syringe from a small vial. Up here, the fluids tend to stick to the sides of the vial. It's very difficult to get the bubbles out when you're trying to centrifuge the bubble to get away from the liquid so that you can just suck up the liquid. It's very, very difficult when you don't have gravity that pulls all the liquid down. And so I think in a lot of the experiments that we've been doing up here, we've seen things where scientists are design their experiment not quite thinking of all of these different factors in microgravity. And we actually saw that with the Auxilium cartridges. There were some differences in the way that the fluids behaved, and also some differences, I think, in the temperature, the thermal control dynamics, because this material inside the cartridge, in order to be fluid, had to be quite warm. And we warmed it to the same temperature that was done at Earth, but it didn't behave quite the same. And I think some of that has to do with the heat transfer properties in a incubator or in a refrigerator. Up here, you don't have the convection moving the air around. So those are some of the things that come to mind that are big differences between working up here in space and working on Earth.
John Paul from Marshall Space Flight Center asks, every astronaut brings a unique expertise to the crew, whether it's medicine, science, engineering, military service, or operations. What part of your background do you find yourself relying on most often aboard the International Space Station, and what part did you expect to use more than you actually do? That's an excellent question, and it also brings the perspective of what set of skills do you want in a crew of astronauts? So I would say for me, with my background of a helicopter test pilot, it might surprise you, but the most important skills that I've learned and that I've experienced my whole career is actually a soft skill. It was teamwork and working with teams inside with crews inside cockpits, and also with ground controls as a test pilot. So you have to be able to work in a very stressful environment, in a very different environment. I also went to serve to Afghanistan to do rescues there, and so working in a complex environment with people around, interacting with people from diverse backgrounds all around. And this, I think, is the teamwork is the most important soft skill that astronaut must have. I am convinced that all of the hard skills, like you mentioned, the backgrounds, you can teach them to people. And so we have procedure to learn how to handle, like, for example, for me, biology. I'm doing biology up here. I never did this in my background, unless it was in high school or at the very beginning, when I was young in my studies. But so all of the hard skills, you can train them. But if you really want to understand what skills are important to build and to really experience deeply in a whole variety of environment, I would say work on the soft skills. Teamwork being the first, and also being flexible, because as an astronaut, you're serving a mission that is greater than yourself. And so you don't control everything. Actually, you control nothing. And so you have to really be flexible to adapt to the operational tempo and everything that happens operationally for the mission success.
Aaron from the Marshall Space Flight Center asks, if you were to isolate a microorganism grown on the ISS, what would the process look like in subsampling, plating, or packaging? Thanks for a great question, Aaron. This is an interesting topic because, just like Sophie talked about, I don't have a lot of experience in doing biology and working with this type of materials here, but it's something that I actually did in the last month or two, as one of our experiments was to swab around the International Space Station in different sections to see what was actually growing. And so I had to learn and follow the procedures and talk to the principal investigators to figure out the techniques to best swab, get those swabs onto media, and then get that media to grow the organisms. And then Sophie actually pulled some of those grow things off of the sample media and put them into test tubes so we could sequence their DNA and see what it was. Challenges here up on the International Space Station as we do that is containment, because we're in a closed environment and anything that we let grow could come back and harm us. So we're really careful about making sure about things that could grow that could harm us are contained and they aren't going to get around and spread. It's been a real interesting experiment to see what kind of things can grow, what kind of things do grow, and also to see how the procedures of biology work in a zero-G and a contained environment where we have to be particularly careful.
And the last question comes from Anthony at Glenn Research Center. Anthony asks, what has been the most significant challenge, whether during training, launch, or life aboard the International Space Station, and how might future engineers help address or improve that issue? Well, one of the things that surprised me the most coming up here was just how much microgravity affects how you do simple daily tasks. Keeping track of things. We will often get bags full of supplies, and you open those bags, and there's 20 different Ziploc bags in this outer cargo bag. And as soon as you open the top of that, everything goes flying in all directions. And so I think it brings back one of the things is, how can we as engineers, and this is a problem in microgravity, and this is going to be a problem that's going to continue to face us in spaceflight. You can see we all have Velcro on our pants, and all of the things, our tablets and everything have Velcro on them so that we can try to keep things in place. But figuring out how to manage and work in microgravity is a non-trivial problem. And I think we've been doing it for over 25 years here on the International Space Station. We still run into problems. And I think creative engineers can think about, okay, well, if we're going to build this piece of hardware, it has to be used in zero-G. So we have to think about how do we design it such that pieces can be repaired? You know, if I take out a bolt, how do we make sure that bolt stays captive and doesn't go anywhere? How do we make sure that when we're loading supplies that that you don't need actually 3 hands to hold it in place, and that a single operator can do it with 2 hands? So I think thinking through, operationally how things are going to be used, given the context of zero gravity, is super important, and is going to be super important for our future missions and our current missions, especially as we go and push further onto longer missions. So it's a great question. Thank you. And that's all the time we have for today. Thank you for tuning in, and thank you to our NASA interns for all of your great questions. Those were fantastic.
Your curiosity, your passion, and your drive are what will propel you into the next steps of your career.
NASA needs thoughtful people like you who are ready to push boundaries and achieve what others think is impossible.
So until next time, stay curious and keep asking questions. Bye-bye.